Hello, my name is a presentation on the trend of one of the physical properties, the ionization energy of period 3 elements. To begin with, what is periodicity? Periodicity is the repeating pattern of physical and chemical properties shown by different periods. Periodic trends can be seen in melting point, boiling point, atomic radius, and electronegativity. However, today I'm going to focus on the ionization energy. So, what is ionization energy? It is the minimum amount of energy required to remove an electron from 1 mole of gaseous atoms. It is measured in kilojoule per mole. The equation for the first ionization energy is this. Q is an element and it's written in gaseous form. So Q is Q plus an electron. I'm going to focus on the period 3 elements. So here's the periodic table. It's from sodium to the noble gas. The general trend of the period 3 elements is the value of ionization energy increases across the period. This is because there are more protons in each nucleus, so the nuclear charge of each element increases. Therefore, force of attraction between nucleus and outer electrons increases. Shielding effect is negligible because each successive electron enters the same energy level. Thus, more energy is needed to remove outer electrons. So in summary, as the proton number increases across the period 3, the nuclear charge increases, and the electrostatic force between the nucleus and the valence electron increases. So it becomes harder to remove an electron, which makes the ionization energy to increase. However, there are some exceptions. If you see in this graph, the ionization energy is supposed to increase from left to right. However, from magnesium to aluminum, it decreases. Have a look at this chart. From magnesium to aluminum, the first ionization energy decreases from 738 to 578. So you might wonder why. Have a look at this electron configuration. The magnesium has 3s2 while aluminum has 3p1. The outer electron in aluminum is in p sublevel. This is higher in energy level than the outer electron in magnesium, which is in the s sublevel. So the electrostatic force between nucleus and valence electron is lower in aluminum. Thus, it's easier to remove an electron and the ionization energy of aluminum decreases. There is another exception. From phosphorus to sulfur, the ionization energy decreases. Have a look at this chart. It decreases from 1012 to 1000. So why does this happen? Have a look at this configuration. Phosphorus has 3p3, while sulfur has 4. In this drawing, the phosphorus has 3 electrons, so it fills the 3 levels. But in sulfur, since it has 4 valence electrons, it fills 1, 2, 3, and 4. So it has a pair, while the phosphorus does not have any pairs. There's electron-electron repulsion within the same 3p orbital, which counteracts the effect of increase in nuclear charge. So it's easier to remove an electron from sulfur than phosphorus. So sulfur has lower ionization energy. So in conclusion, the ionization energy generally increases across period 3, but the trend is not smooth because of the 2 exceptions, magnesium and aluminum, and phosphorus and sulfur. The end. Thank you for watching this presentation.